Okay, so today we're going to do the next section in chapter 6, which is 6.4, and it's function operations with power functions. So you've done function operations before in Algebra 2a, and you've done them with basic linear functions like these two at the top of our notes. So we're going to review function operations with these very simple equations or functions, and then we're going to try these function operations with some of the types of functions we've been working with this chapter, which have those rational exponents. So our exponents that are fractions. So we're going to start out with a review. So we can do addition with our two functions up here, f of x and g of x. If I want to do f of x plus g of x, I'm going to take f of x, which is 2x. I'm going to add it to g of x, which is x plus 1. Okay, so in order to add polynomials, I just need to add like terms. So 2x plus 1x is 3x. So remember, when you combine like terms, you don't add your powers. And then I just have my positive 1 at the end. The next thing we can do is we can subtract functions. So we're going to take f of x, which is 2x again. And now we're going to subtract g of x, which is x plus 1. When I'm subtracting, I need to make sure I subtract everything after the subtraction sign. So one way to remember to do that is to do keep, change, change. So I'm going to keep my first parenthesis, I'm going to change it to an addition problem, and then I'm going to change everything after that to their opposites. So it's going to become a negative x and a negative 1. Then I'm going to combine my like terms. So 2x plus negative 1x would just give me positive 1x, or x, and then minus 1. Multiplication, I can multiply my two functions. So I'm going to take 2 of x times x plus 1. Multiplying here would just mean distributive property. So I'm doing 2x times x. Remember, when we multiply, we add our powers. So we'd get 2x squared. 2x times 1 is 2x. So 2x squared plus 2x when I multiply them. We can also divide our functions. When I divide, I'm going to set it up like a fraction. So I'm going to put 2x on top since that's f of x, and I'm dividing g of x, which is x plus 1, so that will go on the bottom. Now, to actually divide this, really when we're dividing, we're just saying what can we simplify. In order to simplify a fraction, I need to be able to simplify all of my terms. So I'm not allowed to cross out these x's because the 1 doesn't have an x with it as well. And there's no like common factor that I can divide all of these by. So for this one, that's all I can do. Just set it up and I'm done. The last one's called a composition of functions. This is the one that's maybe a little bit more confusing than our basic operations. This is read f of g of x. They're telling us to plug the g of x equation, which is x plus 1, into the f of x equation, and I want to plug it in wherever the variable is, which is right here after the 2. So I'm taking out x, and instead of x, I'm going to plug in x plus 1. It's kind of like substitution when we solve our systems of equations. So I'm going to have my 2. I'm going to take x out right here, so I'm using parentheses because I'm plugging something in for it, and I'm plugging in the g of x equation, which is x plus 1. So here's what this one would look like when I set it up, and then to simplify, I'm using my distributive property. So that would become 2x plus 2. Okay, so we're going to do all of these operations with our power functions, which are our functions that have those rational exponents. Okay, so I'm going to move this down, and we are going to look at these two functions, which is 2x to the 1/2 power and negative 6x to the 1/2 power. And the first thing we're going to do with these two functions is we're going to add them. We're going to do f of x plus g of x. So I'm going to take my f of x equation, which is 2x to the 1/2 power, plus my g of x equation, which is negative 6x to the 1/2 power. Now, just like when we added up at the top, I combined like terms. So as long as these are like terms, I can go ahead and add them. They both have an x to the 1/2 power, which means they are like terms. So when I combine, I'm just doing positive 2 plus negative 6, which is negative 4. And I just leave my x to the 1/2 power attached to it. I'm just combining them together. I don't add my powers. Remember, you only add your powers if you're multiplying terms. So I'm not doing anything with my exponents. I'm just combining these together. So in the next part, we're going to subtract them. So 2x to the 1/2 minus negative 6x to the 1/2. So I'm subtracting a negative. So do your key, change. 2 plus 6 is 8. And again, I just leave my x to the 1/2 power attached to the end of it. I don't add my powers because I only add powers if I'm multiplying terms. Okay? Now, let's say that these powers weren't the same. Let's say these were not like terms. Like, let's say I had something like 2x to the 1/2 plus 6x to the 1/4. I would not be able to combine these or add them. This would be all I could do. I would set it up and I would be done because these are not able to be added. They're not like terms. So something like this might come up, and then this is just my answer. I'm done. Okay, example 2. My functions are f of x equals 3x and g of x equals x to the 1/4 power. First, they want me to find f of x times g of x, so I'm going to multiply them together. So 3x times x to the 1/4 power. Now I'm multiplying. So now I'm going to keep in mind my rules or my properties for my exponents. When I'm multiplying, I add my exponents together. So this x has a power of 1, so I need to add 1 plus my exponent of 1/4. So I'm going to change my power of 1 to a fraction, so 1 over 1. In order to add these, I have to have a common denominator. So I'm going to multiply this by 4, so I can add these together. So 4 over 4 plus 1 over 4. I add my top, 5 over 4. Now, if I had another coefficient right here, I'd multiply it with that 3, but it's just a 1. So 3 times 1 is 3. X, and here's my power of 5 over 4. When I multiply, I add my exponents. Part B, we're going to divide these, so 3x, and remember division, just like we went over on the top, we set up like a fraction. G of x is x to the 1/4, so that would be on the bottom. So remember your rules for exponents. If you are dividing, the rule is you subtract your exponents as long as they're monomials, which they are. So I'm going to put a power of 1 over 1 up here so that I can subtract these. And just like with our addition, I have to have the same denominator to subtract. So I know 1 over 1 is 4 over 4 minus 1 over 4 gives me 3 over 4. Now, if there is a coefficient down here, I'd want to try and divide 3 by it, but it's just a 1. So 3 divided by 1 is 3x, and here's my power of 3 over 4. Okay, so it's like what we've been doing with our exponents. We add the exponents, we subtract the exponents. We are just having to kind of set up the problem first before we do that. They're telling us what to do with these two equations, these two functions. Okay, so a few more in example 3. These are a composition of functions. So this one we want to find f of g of x. So they're telling us to plug g of x equation into the f of x equation. So I'm going to go find my g of x equation first, which is right here. Negative 2x to the 2/3. We're going to plug that whole thing into the other equation wherever x is, which is right after the 3. So instead of this x right here, I'm going to plug in negative 2x to the 2/3 power. Okay, so it's going to look like this. 3. I take out x. I plug in negative 2x to the 2/3. I close my parenthesis, all of that went in right here for x, and I still have this power of 2 that's going to be right here outside of my parentheses. So we're going to take care of our power first, because if you remember PEMDAS, before I multiply and divide, I have to take care of my exponent in my parentheses. So I'm going to distribute my power of 2 to both things inside of my parentheses. I don't need this 3 yet. We'll do it in a second. So negative 2 gets the power of 2. And then x to the 2/3 gets my power of 2. So power to a power, the rule is we multiply our powers. Power to power, multiply powers. When I multiply, I don't need a common denominator. I'm going to multiply straight across. 4 over 3, and you can notice I put 2 over 1 to help me. So x right here, when I do my power to my power, gets a 4 over 3 power. Now I can go ahead and simplify negative 2 squared. Negative 2 times negative 2 is 4. And now, since I don't have a power anymore over here, I can go ahead and multiply 3 times 4, and I'll get 12x to the 4/3. Alright, part B. This one we want to find f of x. So a little bit different. There's no g in this one. That means I'm not even using my g of x equation at all. I'm going to actually use my f of x equation twice. So I'm going to write it out twice to help me. Okay, they want me to plug the f of x equation, which is 3x squared, into x right here. So this is going to replace x. So I'm going to have my 3. I'm going to take x out, plug in 3x squared. All of this went in for x, so I still have this power of 2 outside of my parentheses. From here, the simplifying is very similar to part A. I take my power of 2, it goes to the 3 into my x squared. I still have this 3 out front, I'm just going to bring it down. 3 squared, x squared squared, power to power, I multiply. So be x to the 4th. 3 squared right here is 9. And then I can go ahead and do my 3 times 9 is 27, x to the 4th. Okay. So the last two, as you can see, are a little bit different because they have numbers inside of the parentheses rather than a variable like x. So I'm going to move this down. We're still using those same two functions. This one we want to find f of 8 plus g of 8. So essentially I'm adding the functions together and I'm plugging in 8 for x. That's what that's telling me to do. So you can actually do it two different ways. You can go ahead and you can plug in your 8's first to both equations and then add. Or you could try and set up adding your equations and then plug in your 8's. It doesn't really matter. I'm going to kind of plug them in to each equation and then keep my plus sign in between them. So 3x squared, instead of x, I'm going to plug in 8. So it's going to say 3 times 8 squared. That's f of 8 right here. We're going to simplify it in just a second. G of 8. I'm going to take my g of x equation. Instead of x right here, I'm going to plug in 8. It's going to say negative 2 times 8 to the 2/3 power. So now I'm going to simplify this. I'm going to simplify this, and my two numbers that I get, I'm going to add together. So my answer in this one is going to be a single number rather than something like 27x to the 4th power. So remember, you do powers first. So 8 squared is 64. And then times 3. So 64 times 3 is what? I don't know. I need to get a calculator. I'm going to do it right here. 3 times 4 is 12. 3 times 6 is 18, plus 1 is 192. Okay, I need to figure out what this is. So, first I do my power. 8 to the 2/3 power. So remember, when you have a fraction power, you can always write it as a radical, the cube root of 8 squared. The cube root of 8 is 2. If you plug that into your calculator, it's 2. 2 squared is 4. So this part right here is 4 times negative 2 is negative 8. So finally I'm doing 192 plus negative 8, which gives me 184. Alright. And the last one, f of 2. Similar to this, I could actually use my answer from this one and plug in 2. Okay? So instead of x, I don't want x in my answer, I want to plug in 2 for x. So I believe my answer for this one, let me just double check. Yep, 27x to the 4th. And then so instead of x, I want to plug in 2. 27 times 2 to the 4th power. So power first. 2 times 4 is 16. And then I'm doing 27 times 16. And I'm going to run and get a calculator really quick. And 27 times 16 is 432. Okay, now let's say we hadn't done problem B and we just had this problem without having done this problem first. Okay, so let me, because I kind of cheated, I took my answer from this one and plugged in 2. So one way we could have done it, I can ignore this first f, plug in 2 to f of x, which is just 3x squared. 3 times 2 squared. Simplify this. 2 squared is 4. 4 times 3 is 12. Then I could have taken 12, my answer I just got, and plugged that into x right here. So then I could have done 3 times 12 squared. 12 squared is 144. 144 times 3 is 432. I got the same thing either way. So I could either do f of x first, and then my answer plug the 2 in. Or I could plug 2 into f of x, get my answer of 12, and then plug that into f of x. So 2 different ways you can kind of do that. Okay, so you're going to try your worksheet to the best of your ability. So you're going to go up and show the sub these notes filled out. It'll give you a worksheet. I know you might not understand every single one of them, but please try your best and try and get as many done as you can on your own, and we will go over this again next class.